Hi, this is Dr. S and welcome to video 5 of my series on reaction rates for Year 13 A-Level Chemistry. In this video we're going to introduce the idea of the continuous rate method as a way of determining the orders of reaction, but specifically we're going to look at colorimetry. Now, continuous rate methods you have met before in Year 12. These are experiments in which you can monitor how much of a gas, for example, is produced every 10 or 20 seconds, so we can get a graph which then contains time and concentration or volume or something else that you can create a graph from, and you often get a graph such as this. Now at Year 12 they generally revolve around gas collection because they are easier, so you can look at my Year 12 revision videos to remind yourself of that. In Year 13 though, we need to look at how we can do this with solutions. Solutions are a bit more tricky and they need a special piece of kit in most cases. Now what we can use is a colorimeter. A colorimeter is a piece of equipment that allows us to determine the intensity of a colour of a solution. So in order for this to work, we need to have a reaction that involves a coloured solution. The most common of those would be something involving iodine or bromine. These both have a colour. So the more intense the colour, the higher the concentration. A colorimeter will give us a value of the intensity of the colour. So let's say we were doing an experiment that produces iodine. So as the reaction goes on, the brown colour in the solution will get darker and darker and darker. So we're going to look at how a colorimeter works and how we'd be able to use it. A colorimeter is a piece of equipment that allows you to put a small sample tube of a solution into effectively a light box. Then what we do is we pass light through the solution, so we're going through the solution, and it reaches a detector. It then gives a value, a numerical value. Now all colorimeters are different, let's just say it's 1.20. There's no units in this case. The light has to go through a filter in order to make sure that the colour of light, the wavelength of the light, is appropriate for that particular solution. So what this detector measures is how much light is getting through to the detector. In other words, how much is the solution absorbing? And the more intense the colour, the more light it would absorb. Now, as I mentioned, the problem with a colorimeter is that this value doesn't really mean much. There's no units, there's no standard scale even for a colorimeter. Every colorimeter is slightly different. So what you need to be able to explain is how we would calibrate a colorimeter. So in that case, what we'd do is we'd make a calibration curve. So what we'd have to do in this case is we'd try and get a graph of concentration against absorbance for that particular colorimeter. So what I might do is select different concentrations of iodine. Let's say 0, 1, 2, 3, 4 moles per decimeter cubed. And I'd run the colorimeter with each of those samples. I would then get a value of absorbance from my colorimeter, my specific colorimeter, and that should give me a linear result. What's this, just a sketch graph? But we should be able to get a straight line from our calibration curve. Remember, that's with known concentrations. Then what we can do is we can use our sample, which has an unknown concentration, put that through the colorimeter, read off the absorbance from the machine, and then from this graph that we've made, the calibration curve, we could go to that particular absorbance, go along to the line, and then read off the concentration at that point. So if you imagine what the aim of this is, the aim, remember, is to get a time against concentration graph. So what I would do is every 10 or 20 or 30 seconds I'd run the colorimeter, take the absorbance, calculate the concentration from that, and then plot it onto a concentration time graph. And again, I might get a graph like that showing the production of iodine in this case. Okay, I hope you can see the link between this and the gas collection methods from year 12. This is slightly more complicated because it's solutions. There are other ways of doing solutions as well, but they're beyond the scope of the A-level. Okay, so in my next video we'll look at how to use the concentration time graphs to determine the orders of reaction of each of the reagents. I'll see you then.